So we talked about an Arrhenius definition of acids. An acid is something that forms hydrogen ions or hydronium ions in solution. And we talked about the Bronsted-Lowry definition, where an acid is a proton donor. There's a third one called the Lewis definition. Here we're not focusing on the hydrogens, we're focusing on electron pairs. So an acid is an electron pair acceptor. A base is an electron pair donor. So here we've got ammonia, and is that an acid or a base? That's a base, right? We're supposed to just know that. This nitrogen has a lone pair on it. It has a hydrogen, and we could say, well, maybe it could be an acid. It could donate a hydrogen. It doesn't, though. But it has this lone pair. And so this lone pair is what can bond with the proton from the acid. So this is accepting a hydrogen ion. What it's doing, though, is it's donating the electron pair to the hydrogen. So the Lewis model is focusing on the electron pair. Wait a minute. That's backwards. No, it isn't. Sorry. Brain fart. That's what my husband calls it. This is the new definition. I got Lewis model and Lewis structures mixed up in my head. So the Bronsted-Lowry model, what we were looking at the proton. The donated proton, accepted proton. Here, the Lewis model, we're looking at the lone pair. So we're just looking at the other side of the same thing. And this is important because the first two models of acids and bases don't work in all situations. So a Lewis acid doesn't have to have hydrogen. Up until now, this is a turning point in your life. Up until now, hydrogens were important on acids. If it didn't start with a hydrogen, it wasn't an acid. And that's true for those first two definitions. It's not true for the Lewis definition. BF3 doesn't have a hydrogen on it, but it is a Lewis acid. This is a base. It's a Lewis base, a Bronsted-Lowry base, an Arrhenius base, all of those. This has this lone pair that can donate it can donate these electrons to the Lewis acid. So the Lewis acid receives the electron pairs, the Lewis base donates. So looking at electrons versus hydrogen ions, electrons versus protons, so it's opposite, right? Because one's positive and one's negative. Boron trifluoride, this is one of those guys that has an incomplete octet. And so it's got this empty orbital, and this lone pair can go into that empty orbital and form this guy, which is called an adduct. So Lewis acids are going to have an empty orbital, or they can move things around to make an empty orbital to accept the electron pair. So molecules that have incomplete octets will act as Lewis acids. So here we have aluminum trichloride, and aluminum has an incomplete octet. Look at its Lewis structure, it's only got 6 electrons here instead of 8. So this lone pair from nitrogen can come in here and complete that octet. Here's BCl3, again, incomplete octet. Here we've got, this is actually an ether. It's an organic compound. It's got an oxygen here with lone pairs. This lone pair can connect with this boron that has the incomplete octet. So this is the acid, and that's the base. You'll use a lot of this in OChem. So molecules with incomplete octets, some molecules can rearrange their electrons. This also happens a lot in OChem. So here we've got carbon dioxide. And carbon dioxide doesn't have an incomplete octet. Carbon has 8, each of the oxygens has 8, but it can rearrange. So what happens is a pair of electrons from this double bond rotates up to the oxygen. And a lone pair from water, acting as the Lewis base, comes in to replace that. So then you've got this guy. And then what happens is this lone pair on the oxygen will bond to this hydrogen. So the hydrogen is receiving the lone pair, the oxygen is donating the lone pair. And so we get carbonic acid. That's a little taste of OChem for you. There's a lot of drawing curved arrows and moving electrons around. There's not much math, though, for those of you that don't like math. The math in OChem consists of mostly counting to 10 or less. Can you count up to 10? You're good math-wise in OChem. Any questions? I think this one falls in the category of I'm so lost I can't even ask a question. Yeah.
Something like that be on the test?
There might be one question about Lewis acids. Yeah. So this is another one of those topics that you need to learn about, but if you don't become proficient in it, it's not going to cause you to fail the class. If you can't do an ice table, you're going to have trouble. So we talked about molecules with incomplete octets, molecules that can rearrange their electrons, and then also some cations can act as Lewis acids. So these are generally small, highly charged metal ions. Does that sound familiar? Yeah. On Monday, we talked about different cations and anions that act as acids and bases. And we said there were 2 small, highly charged metal ions that you needed to remember. And what are they? Aluminum and Fe. So the ones I want you to remember are Fe3 plus and Al3 plus. There are others, but I don't expect you to know that. And I don't know why. I think this is Iron Man and Al. So those are the 2, Iron Man and Al. So here's aluminum 3 plus. Its valence orbitals are empty, right? So here we've got 6 water molecules, and they've got lone pairs. And so they're going to donate lone pairs to the aluminum. The aluminum is accepting the lone pairs, so it's acting as a Lewis acid. The water is acting as a Lewis base. And so then we end up with 6 of these around the water, around the aluminum. And that's the picture we saw. We saw the aluminum with 6 water molecules around it.